Hey scholars, we are working now with something you've actually seen before, so we're going to develop it just a little bit and expound upon it. But we worked with the other day how to simplify radicals, and all because we're actually working with right triangles in geometry. And right triangles come up in everything, and to find missing parts of a right triangle, we're going to use a lot more radicals. So let's just remember the first part of the different parts of a right triangle. What do we always call the longest side? This should be the hypotenuse. Now remember, that should make sense. If we remember back to our three bears, you have three sides of a triangle. You had the papa bear, mama bear, and baby bear. Sometimes they're the same size, but then we know their angles correspond with that. Well, the largest angle on a right triangle is the right angle, so its longest side is always opposite that, and that will always be your hypotenuse. The other two sides we call leg. So those are the legs of it. Now, remember also another thing, the acute angles of a right triangle equal 90 degrees. That means they're complementary. Let's just say add up to. I think I like that better. Add up to 90 degrees. Okay? Their sum is going to add up to 90. So it really kind of keeps it simple, but it also helps us solve for missing angles well. But now, we actually had this memorized last year in Algebra 1. When you learn radicals, you learn how to do the Pythagorean theorem. It says the following: in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Now, this is one of the most proven formulas probably in geometry. There's hundreds out there. There's visual, there's mathematical, trig associated, it doesn't really matter. But a lot of you would have said this: a squared plus b squared equals c squared. Now here's my thing about saying that. What does a, b, and c mean? If you have a, b, and c, you don't always know what it does. People just always assume the missing one's c. Well, that's not really the case. So what I want you to think about, it's really leg squared plus leg squared equals hypotenuse squared. And so you should always be able to keep that. But when you are working with this, and if you decide to use a squared plus b squared equals c squared, remember c is always the hypotenuse, not the missing one. So we always want to keep that in mind. Now, so we have the three basically parts that work in the Pythagorean theorem. Well, we have a thing that's called Pythagorean triples. Pythagorean triples are the sets of three non-zero whole numbers that work in the Pythagorean theorem. You will have pop quizzes all semester over these. The reason why we learn them is to help you on standardized tests. It saves time, but also saves time on quizzes and homeworks, and it just works well for pre-cal. There are 11 sets of three numbers you have to memorize, and we're using the fact that they make right triangles. So the first one, this first set is the smallest Pythagorean triple that works. Now remember, these have to be whole numbers, and it's just 3, 4, 5. So leg, leg, hypotenuse. These automatically work in the Pythagorean theorem. Our next one is 5, 12, 13. And I will teach you tricks as we go how to memorize these every few days. The next one is going to be 6, 8, 10. The fourth set you have to know is 7, 24, 25. The fifth set is going to be 8, 15, 17. The sixth set of numbers that you have to know, and you're not going to have to memorize them in order, you're going to have to know these sets of numbers, just recognize them together, is going to be 9, 12, 15. The seventh one is going to be 9, 40, 41. This is one of those that the smallest leg actually has two different groups it goes with. Then you have 10, 24, 26. Make sure I'm running out of spaces here, so we're going to have to add a few more on. The ninth one is going to be 11, 60, 61. The 10th one, and you're going to actually have to know 11 of these, so understand you have the 11th one here. It's going to be 12, 16, 20, and then you have one that's 12, 35, 37. Now some of you are like, I can't memorize these. Actually, you really can, and it's easy A's. They count for a full quiz grade. It's a great way to help your grade. But what would it look like? What would you have to do? It's when you have a right triangle like this. I'm going to give two sides of it, either a leg and a hypotenuse or both legs, okay? And I'll sit there and say, okay, this one's 12, this one's 13. What's the missing side? Well, if I have a hypotenuse of 13 and a leg of 12, what's the missing one? X would have to be 5. I don't have to punch into the Pythagorean theorem. Now, let me give you a few hints on how to memorize this. 3, 4, 5 is the most basic multiple, a Pythagorean triple. You can get more Pythagorean triples by doing called multiples. Notice if I multiply every one of those by 2, I get 6, 8, 10. So 3, 4, 5 goes to 6, 8, 10. Notice if I multiply every one of those by 3, I get 9, 12, 15. Oh, look. That's another one of the triples. Or what if I do it by 4? Well, that's 12, 16, and 20. So right away, if you know 3, 4, 5, you should have 4 other ones memorized. Another one that's really easy to do is if you start with an odd number, square it. What's 5 squared? 25. Well, guess what 12 and 13 add up to? 25. So it works out pretty well. So hopefully that will kind of get you started, but we will talk more about this. I will show you. You will have a Pythagorean triple quiz next week. So next week, block days. No, these have to be memorized. And this can really help your grade, or it could really hurt your grade. So these have to be memorized. All right, so we're going to go to the next page, and we're going to do some practice problems with the Pythagorean theorem.